Hi, I'm Cheryl Leach. In this problem, we're going to be finding the slope of the graph of an equation at a given point. The particular equation we're going to be looking at is y plus xy equals 4, and we'll be trying to find that slope at the point -5, -1. Well, what exactly is the slope? We know that you can find the slope by using the derivative. But when I look at my equation, I have x's and y's all mixed up inside of the equation. Am I talking about dy dx or dx dy? It's not clear. Well, let's think again a minute about what that slope is. The slope is going to be the change in y over the change in x when I'm looking at the tangent line to the curve. Because of that, I know that the particular derivative that I need is dy dx. So what we need is dy dx, because that's going to give me the change in y over the change in x, which is our slope. Well, now that I've determined which derivative I want, I need to go ahead and find it. But this equation isn't solved for y. Now, in this case, it wouldn't be that hard to solve for y and proceed with my usual differentiation rules. However, that won't always be possible. So we're going to practice a technique that will allow me to find the derivative whether or not my equation is solved for the dependent variable. It's called implicit differentiation. And we start out by taking the derivative of both sides, like we always do. So if I take a look at the left-hand side of my equation, I have a sum. So I'm going to start out with my sum rule, which means I take the derivative of each piece individually. So what is the derivative of y? Now remember, we're looking for dy dx, so I'm taking the derivative with respect to x. So this first derivative is simply dy dx. Next, I have to take the derivative of x times y. This is a product, so we're going to use the product rule. And the product rule, if you remember, tells us that we take the first term, which is an x, times the derivative of the second term. The derivative of y, again with respect to x, is dy dx. Then we add the second term times the derivative of the first. Well, what's the derivative of x with respect to x? That's just 1. And now I have my product rule. The left-hand side is now complete. Next, I have to take the derivative of the right-hand side. Well, the derivative of a constant is always 0. So what have I done? I've differentiated both sides. So now what? The next thing to do is to collect all the terms that have a dy dx and keep them on one side and move everything else to the other side. So first we'll do a little bit of algebra. We'll write this as dy dx plus x dy dx plus y equals 0. And I'm going to keep these first two terms on my left-hand side, but move that y over to the right. So dy dx plus x dy dx is going to equal minus y. So what have I done? I've collected my dy dx terms on one side. Okay, so we're making some progress. Notice on the left-hand side that everything now has a dy dx, so I can factor a dy dx out. And I've got the quantity 1 plus x times my dy dx, and that equals -y. So again, what I've done is I've factored. The last step is to actually solve for dy dx. And I can do that by simply dividing both sides by 1 plus x. And so that last step in my implicit differentiation is to solve or divide to get my dy dx. So I've now differentiated implicitly. I'm not quite done yet though, because I want to know what that derivative is at the point -5, -1. The only thing remaining is to plug in the -5 and the -1. So my slope is dy dx, which I now know is minus y divided by 1 plus x. And at the point -5, -1, I'll have minus a -1 all over 1 plus a -5. And with a little arithmetic, I end up with a slope of -1/4. I hope this helped. Thanks.